Can everybody hear me properly? Is my microphone properly working?
Yeah, it's good for us. You have a little more than 20 minutes if you want.
That's very good. So I'll make sure to finish by 16:05, just to stick to my time slot. So nice to meet you, everyone. I'm Dimitri from OneBonsai. OneBonsai is a virtual reality design and development studio. So we've been working for the last 3 years building professional applications for a variety of clients, some of them in retail, some of them in military and defense, some others in heavy industry, and so on and so forth.
Oh!
I will start this keynote with a bit of shameless self-promotion, and then I'm going to go into the core of the topic, which is the matter of return on investment on a virtual reality project. So just to show a bit the kind of projects that we've been doing, like for example, a crane simulator training to train crane drivers in virtual reality. Industrial safety trainings, training industrial workers on specific industrial trainings, so safety procedures and things.
Il est en train de présenter quelque chose là ou pas sur les
Fire
slides?
trainings, both for
Ouais,
regular office
moi, j'ai
workers
pas
and
la
also
vidéo marche pas,
professional
quoi.
firemen, and so on and so forth. So today I'm going to actually address something really different. Is I'm going to give you an example where that's what I'm going to try and demonstrate, like that the cost of not doing virtual reality and augmented reality is going to be superior to the cost of doing virtual reality and augmented reality. And so there's also something that I would like to point out, is that virtual reality is actually not the present. Like there are a lot of use cases that are actually already being used, already going on, and so on and so forth. And so what is missing at the moment in the virtual reality landscape is business cases and return on investment. Like we hear a lot about this virtual reality project, that virtual reality project, but where is the return on investment? Where is the data? Well, actually, most companies don't measure their return on investment. They are confused by, the abstract statistics that are implied, and the ones who do measure their return on investment typically don't disclose their data because they're obviously powerful competitive tools. Us at OneBonsai, we always make sure to measure our return on investment. And so this is something that we're going to share with you today. A little disclaimer, the client name is not disclosed, and the images I'm going to show are only for illustration. So for a hospital here in Belgium, OneBonsai is a Belgian company, we have done a digital twin of a surgery room. So that Belgian hospital is in the process of creating that surgery room. They're actually building it right now. And before the project, we actually made a digital twin of it. That digital twin is a full virtual reality reproduction of it in all its details, and has been used by the hospital to check if the surgery room makes sense. Why do they check if the surgery room actually makes sense? Is because when you build a physical surgery room, you basically build the surgery room itself, but then you also have to build all the neighboring rooms and all the neighboring elements of the building, meaning that you're going to have the operating theater, but the floor under it is going to be a ventilation unit. The floor on top of it is going to be a filtration unit, and then you're going to have all the clean, green, white access rooms, and so on and so forth. And so what I'm going to do is go through something that's going to be a bit heavy, but it's actually a cost estimation of modifying such a surgery room. So I'm going to compare two columns, the traditional approach and the virtual reality twin approach. So if you focus for now only on the traditional approach, when you actually do one change in an operating theater, the average cost of it is about 320,000 euros. It's some changes cost more, some changes cost less, but the typical one-time change in a surgery room costs that amount. And the average number of modification that you are doing after or during the construction of a surgery room is about 6. And so we've seen it with the help of our virtual reality twin that complete cost of building and maintaining the virtual reality twin for the year before the construction works began cost about 550,000 euro. And it happens that the number of modification during and after has actually been only of 2. That means that we have actually spared 4 modifications to the surgery room, resulting in a cost reduction of 1.3 million euro for that specific hospital. So that's a return on investment of already 160%. It's already a massive cost reduction by investing in the creation of a digital twin before doing the real surgery room. That's not all. That's not counting in the opportunity cost of a construction delay. So these numbers are very difficult to measure. There's little data available, and they're also a bit controversial because they are very related to public money and public expenditures. But we still made it through and got to compute them. So if you focus for a moment on the column with the traditional approach, as a matter of fact, the average price, the average cost of existence of a surgery room is about 55 euro per minute. It's actually the charge of the surgery room per minute. Whether it's being used or not, that's just the fact that it's there, that's the money that it costs. When there is one change done to a surgery room, the induced delays is almost 2.5 months. Again, it takes that kind of time and that kind of budget, because if you do one change in a surgery room, you have to redo basically all the parts around that surgery room in the hospital. So if you combine the 6 changes that were required with that time, you realize that it's actually 14.5 months of average induced delay. So with our virtual reality twin approach, given that we have spared 4 modifications, well, we reduced this 14.4 months to actually only 4.8 of average induced delay. So we basically saved up almost 5 million euro in opportunity cost of that specific surgery room being delayed. So that's again a return on investment of like almost 300%. These are the kind of return on investment that we are able to quantify physically, but there are a lot of other aspects that we are actually not able to evaluate because there are no data for it. For example, what about all the changes that would not have happened if we didn't have a virtual digital twin of the surgery room? What would have happened if you when you have the digital twin, it's easy to try and modify it and do a lot of small tests. Like there are a lot of these small changes that they've done that they wouldn't have done in the real life surgery room because they wouldn't want it. The change wouldn't have been worth the cost of delay and additional construction works. We didn't take into account the cost of saving the savings that are done on training the paramedical personnel before the specific surgery room is created. Because once you have the digital twin, you can use it for engineering and design and like these digital applications, but you can also use it for training your people. And we didn't account for the cost that you save on like all the public visits, the demonstration, and all the engineering work that has been done thanks to this digital twin. That's a concrete example where you see that the cost of not doing virtual reality or augmented reality is actually much higher than the cost of doing it. Like these kind of projects have huge return on investments by taking the investment of doing a virtual reality thing. So you're gonna say, yeah, but like, what does it mean? Like I apply VR to anything and I have a positive return on investment? Well, actually no. Like you can prioritize specific projects against others. For example, if your current solution is either very big or very expensive or dangerous, then you can be sure that virtual or augmented reality is going to be able to help. Why? Because if it's big, expensive or dangerous, well, making a digital twin or making a virtual reality version of it is almost every time going to give you a positive return on investment. That's what we are doing at OneBonsai. So we are busy preparing an entire catalog of virtual reality solutions for a variety of fields. Like we are preparing first aid trainings for healthcare. We are preparing industrial safety trainings that are standardized, industrial procedures trainings that are all readily available. And all these different trainings are going to be available in a convenient to use dashboarding system for the managers of one set company. And the point of all these trainings is to actually give real-time feedback about how your people are actually doing and how they're actually operating the change and how they're actually incorporating the thing. So this gives me 7 minutes left in my presentation, which I would like to invest in answering your question, guys. Does anybody in the room have a question for me?
Before we dismiss this presentation.
Philippe Lebras, who asked, okay, you can actually move your VR room anywhere in the world. So it's actually true. There is still one thing about the specific example where the construction of the surgery room has to take into account the specific geolocation of the planned hospital, if you see what I mean. So if the hospital is being built on a specific slopey environment, for example, you have to take this into account into the engineering maps. And so what do I mean by traditional approach? Well, by traditional approach, I mean not doing a digital twin of the surgery room. So what happens when you don't do a digital twin? Well, you basically engineer and design the surgery room based on maps and schematics. So you end up with like 2D representations of the things. Like you don't have a way to actually immerse yourself into the surgery room that has to be created, and you don't have a way to actually act out specific surgical operations to see how well your surgery room layout fits the work at hand. And so yes, when I say VR twin, virtual twin, it is actually a very heavy, super detailed clone model, 3D model of everything inside the surgery room. And this is something that you can access with immersive VR. Not really with the standard hardware, but with like specialized equipment, you can access this virtual reality twin with a headset. And
Sorry,
so
to make sure I properly understood,
Yeah.
I'm the one who asked the question. I'm one of the speakers after.
Yeah.
That you cannot, it's too heavy to be visualized in VR headsets, for instance, or in a cave or whatever.
So the way we do it is we basically have the high detail representation of it, and we have a low detail representation of it. So another question that's asked right before yours, David, is okay, what game engine do you use? We actually use Unreal Engine, and we completely exploit the level of detail feature of Unreal Engine in order to achieve that. If that answers your question, David.
Yeah, but I would be very curious to see if you have experienced running a VR experience versus a non-VR, and compare the return on investment. Apparently, you're mostly comparing the ROI of doing a digital version of the virtual surgery room versus non-digital or pure CAD but non-interactive.
Yeah.
So I hope that's something you'll be working on, and will be probably very interested in having some kind of results regarding that part.
That's a pretty interesting thing, David. So what it might suggest is that I didn't expose it clearly enough. So what I'm comparing with the traditional approach is the traditional CAD approach, like without virtual reality visualization. So for these previous surgery room things, they actually did have basically CAD files, you know, like a full representation of the surgery room in an Autodesk product line and these kind of things. What they didn't have was the fact that you could immerse yourself in virtual reality inside of it, and you could ask specific surgeons, you could invite them to actually put a headset on and try out specific you know, surgical operations and things like this.
We will have an interesting discussion during the panel regarding the benefit of CAD versus real time, and maybe how both can be combined.
True,
okay,
true that, yeah. So I have 2 minutes left. I'm gonna go for Christian's, like Christian Fouch is asking, what tools are you using to evaluate the modifications done to the virtual twin? Well, we don't really have, I mean, we lost count of the amount of modifications done to the virtual twin. Like what we did count was the difference between the average number of modifications that is typically happening in Belgium and the one that we had like in our specific project, if you see what I mean, Christian. So I hear that some of you missed part of it, part of the presentation, and so as Amy is pointing out, there will be a recording available for those who missed some specific parts. Amy is telling me on the side that I have a bit more time until 16:20. So if there are additional questions, I will be happy to answer them. Some of you are typing in the chat. I'm just waiting until your messages are complete.
Yeah, you can unmute your microphone if you want to ask directly to Dimitri.
Does anybody have a remaining question?
It's funny, Dimitri. This morning, everyone wanted to talk, and this afternoon, nobody.
It makes sense. Like I would also be quite impressed. However,
I prefer to use chat.
So I have a question from Aurélien. Do you mean using the mockup in VR is far worth in terms of return on investment? Well, not really. So what I'm comparing is not using the immersive version of it compared to actually using it. That makes sense to you, Aurelia?
There's another question from Sasha Pascal.
What do you mean by DT, Pascal?
Digital twin.
Ah, digital twin. So, what other kind of digital twins did we do? Well, actually, the other digital twin that we've done in the past, but this was one of the early projects, so it's less communicated about. It's basically for some kind of construction site. But like in our experience about digital twins, this one is really the one that we worked on.
Good afternoon. Can you hear me?
Yeah, I can hear you fine.
Yeah, yes. I'm working on real-time 3D with Unreal, and I had a look on your website, and I saw you propose a wide range of training for the industry, and
Yeah.
I was wondering what kind of interactive device do you use? For example, there was, I don't know the word in English, a training on a tour. You can't use an Oculus helmet and just the usual device. What kind of other interactive tools can you use? Can you propose?
Well, on specific trainings that contain specific equipment. So you're taking the example of a tour. So I don't know either the word in English, but it's basically a piece of industrial equipment. We basically use mixed reality tools. So most of the times these kind of trainings are HTC Vive based, and they exploit basically Vive trackers with some specific hardware integrations in order to allow the users to train directly on the real device, so to speak. It's a mix of hand tracking and the real life device for these kind of trainings. A typical example that we have seen a lot is people doing fire extinguisher trainings. It's typical to use a real life fire extinguisher hooked up inside the virtual reality simulation. So tour is called a latte in English, indeed. Problem, Marie. So Andreas is asking if we are defining what has to be tested before starting modeling.
Yeah.
So it's well, often we always start with a good intuition of where we are doing when we do a digital test, digital twin. Like, okay, we are reproducing a specific environment because the main objective maybe is to train the people. Maybe the main objective is to check the installations for ergonomics or logistical optimization, things like this. What often happens is that you start with a simple version of the digital twin, and then you move from there. So it's a bit of I could even say improvisation down the line, meaning that you're gonna start with a simple version of it. You're gonna see already what the users are actually the most interested about with it, and then we basically improvise from there. So and like sometimes the client is going to want to actually expand the digital twin in terms of level of detail, because that's maybe something that's interesting for him, or maybe he's going to want to go more into the technical aspects of the digital twin. So all the technical shafts and all the engineering aspects of the building, or maybe they are going to go more into expanding the whole environment around the digital twin, and so on and so forth. So it's really, when you start with a project like this, don't really know in advance where you're going. You just start with an intuition, and then you adapt the digital twin to whatever it happens to be the most used for. So the Philippe Lebras is actually asking, okay, but the Lathe project, that must be like for school or something. So such trainings are a completely different model. So they are typically much less expensive. So if you look at the kind of VR trainings that we do, like here I have kind of a list of them. These trainings are, they are not a very expensive project for a very specific use case. They are a general training that can be used by many different companies. And so these kind of virtual reality trainings typically go down for 18 to 30 euro per session, per trained user. And for that kind of value price, actually the equipment training actually rock in terms of profitability, because a typical training session of a typical industrial operator is typically going to be around the 200 euros per half day, something like this. So reducing this all the way down to 30 is almost always a good bid for an industrial client. That answer your question, Philippe? So indeed, if you're interested in more, myself, I'm gonna stick around after the presentation, and I also have colleagues of OneBonsai in the room, so you can find us because we have OneBonsai written in our username, the one that floats on top of our heads. So if you have questions or further explorations that you guys want to do, don't hesitate coming to us. So to answer to Frank, yes, there is a recording that is being made by the organizers of Laval, and this one you will be able to access through a YouTube link that will be shared afterwards. Does anybody else have a question for me before I end this presentation and we go to the next presenter? So I get another question, which is, have you done any studies with skill transfer? So that's a very interesting one, and it's also a very tough one. So in terms of skill transfer, it's mostly a question about retention. So at the moment, we are really at the beginning of our virtual reality training system, and so especially next year, when we will be able to compare the learning metrics from this year with next year's, that we are going to be able to basically do some A/B testing, and that's going to be possible only for the clients who actually already measured their training performance before. Like most of the clients that do training actually don't let their people do exams. They just give the training and don't do any form of examination. So it's only for a minority of them that we will have the data available. And so does the accuracy of the simulated environment match to the real world experience after the training? So that specific question is known in the field as the question of representativity. Like, is a virtual training representative of real world? And actually, it happens that it is. People successfully transfer the skills that they learn in virtual. They successfully transfer it in real life. And at the beginning of your message, Ketoma, you ask, is it like is the accuracy of your simulated environment good enough to actually achieve that representativity? But it's actually less about the precision of the environment and more about the more about the fact that the key learning points are clearly highlighted and clearly insisted upon inside the virtual reality training, if you see what I mean. What I mean is, if I kind of reformulate it to make it as clear as possible, is like when you do virtual reality trainings, the graphical fidelity is actually less important than the pedagogical content. It's a bit like here, us now today, like in this virtual reality conference, like the graphical fidelity of it all is really low. Yet we still have the conference experience that we expect to have, and everyone here will still forge the same, like similar memory levels, much more than what they would have if they would have just like followed, a YouTube presentation and so on and so forth. So is there a big demand for digital twin solutions? Well, yes. Actually, for everything, any engineering industrial project, a digital twin is going to save you money. There is one thing though, is that like a digital twin, that's something that is already being done. I don't know any decent engineering company who is not going to do a digital twin for a given project. What is less done is the virtual reality accessibility of these digital twins. Meaning, can you actually enter the digital twin with a virtual reality headset and have the spatio-realistic view of the place or the tool or the object that you're actually designing and engineering.
Okay, thank you so much, Dimitri. That was a great presentation.
Well, thanks to you, Amy.
And we're just going to take a very quick 5-minute break. So if anyone needs to grab a quick coffee or a glass of water, have a quick chat, feel free to do so now. And we'll be back in 5 minutes with Edward Martin from Unity, who's going to be presenting a presentation on driving business value with real-time 3D. So we'll see you in just a few minutes.